Okay, well, hello everyone. It's nice to see you all. Yes, I'm presenting here with Mike Englert and also on behalf of Upmanu Lall, who's not able to be with us today. But we also have a larger, what we call the Aging Dams team. And so some of this work will bridge to some other work that's going on. So I've listed some of the others working on the project as well. So we'll be talking about assessing the vulnerabilities that are associated with high-risk dams in Utah. Why are we looking at dams? Well, you can see from this map that there are an awful lot of them in the United States. We certainly have over 90,000 of these dams. And the issue is that their average age is 64 years. These are getting old. They are getting older than their expected lifespan, and that may have some structural vulnerabilities associated with it. We also see that 76% of these are high hazard dams with an emergency action plan. So we certainly have some vulnerabilities related to our dam infrastructure in the United States. We are also seeing increased risks of prolonged hydroclimatic events, precipitation events, and then this aging infrastructure is a compounding threat coupled with some of our impacts of climate change. The button was working so nicely. Anybody have a fix for that? There we go. Okay, great. What we've wanted to bring to this assessment of vulnerabilities is a more multidimensional approach to looking at the vulnerabilities, thinking about a sets approach, a social, ecological, and technological approach to avoid some of the unidimensional assessments that can be done when we look at things in a singular lens. So we can avoid those narrow assessments that don't get at the interactions and the interdependence of the vulnerabilities together. So we're really coupling this in a big picture, the extreme precipitation events, those vulnerabilities, those risks, the risks of the aging structures, and then these vulnerable entities that are in the social, ecological, and technological realms downstream. There we go. So we have looked at Utah as a case study primarily for two reasons. One, it's convenient, it's where we're located, but more importantly, there's an availability of inundation maps for all of the state regulated high risk dams. That's 234 dams. There are also 33 federal dams in Utah, and we're working with the Bureau of Rec to actually incorporate that, but we haven't done that just yet. But that is really an unusual case in the United States. A lot of states don't release that information, those inundation zones. So we are lucky to have this relationship with the state of Utah to be able to have access to this information. And so you can see out here that the average age of these Utah dams is 65 years. So we're right about at that national average where we have those structural vulnerabilities factored in. Let's see, I think I went too fast. So yes, as you look at the attributes of the dams, we've got dams that are at varying heights. We have dams of varying ages. And so we have a nice, robust data set to work with as sort of a prototype that we can then take to look at, to develop a geodatabase and to develop a protocol for looking at any dams anywhere. But so this gives us a good start. All right, I'm going to turn things over to Mike Englert for a minute.
Good morning, everyone. So we've taken this social, ecological, technological approach to assessing these aging dams. And within those, we're looking at the hospitals, populations under the social vulnerabilities, the GAP status 1 and 2 protected areas. So those are ecologically protected areas. And then under the critical infrastructure technological side, we have natural gas pipelines, railroads, major highways, wastewater treatment plants, power plants, hazardous waste sites, and aviation facilities. And then each of these vulnerabilities has attribute data, including the dam. And so we're able to use that attribute data to get really an in-depth look of what's going on within an inundation zone. And so what we did is we took these 234, which were in one large shape file, and we essentially broke them apart into individual shape files for each individual dam. We reran the spatial intersects with those different vulnerable entities to determine, okay, what's happening within a single inundation zone, thereby creating a profile for each individual dam that we could then go in and individually assess what's going on. And so across the state, what we found is we have 155 designated places, so cities, towns, essentially urban populated centers of varying size, 13 hospitals, multiple miles of natural gas pipelines, major highways and railroads, 8 wastewater treatment plants, power plants, has 1 hazardous waste site, 33 aviation facilities, and 26 protected areas. Many of these intersected vulnerable entities occur in multiple different inundation zones, just kind of based on the geography of Utah. And we'll see a little more about that. So with these inundation profiles, to really get a sense of what's going on, we looked at and assessed them individually using satellite hybrid imagery with the overlaid inundation area to see what's going on. And through that, we determined kind of fit them into three different codes. So code 1, there was no apparent structures within that inundation zone. 2, there was 1 to 5 structures that were kind of unclear whether or not they were habitable or not. And then 5, clearly there's human habitation happening within that inundation zone. And so across the state, here's Utah. And 1 is these purple squares where there's no apparent, and those are happening mostly in rural areas. The triangles where there's 1 to 2, similarly happening in rural areas. And then the main areas where we see a lot of intersection with these populations is in urban dense areas. So this is the Wasatch Front. You have Salt Lake City, the Salt Lake Valley, Ogden here, and the Provo, Utah Valley down here. And a lot of these dams are in the mountains up above these urban centers. And so in this case, we have a dam in a rural setting up above Provo, Salt Lake area that's 84 feet, not holding like a ton of water, but it's coming down and intersecting a large urban area. So here you can see the dam is up here. The inundation zone travels all the way down this canyon, down this state route 92, and then hits the urban area of American Fork and spreads out and covers a very large territory, potentially impacting, you know, hundreds of people and lots of industry and so forth. And so here you can see we have a hospital and an aviation facility within the inundation zone, along with a railroad, a major interstate, and so forth. So that's just one example of what we're seeing in the urban area. In the more rural areas, we're seeing some of the things where we have some large reservoirs, but they're hitting some different kinds of areas. And so here we have this really long inundation zone that travels for miles and miles down essentially a canyon route. So it just follows this canyon and funnels down for a long ways, intersecting White Mesa, and then it's not popping up on this map, but a smaller community called Blanding. And then that spreads out into the San Juan River and impacts this protected ecosystem here right by the river's edge. So that kind of shows you what of the geographic phenomenon that we experience in Utah. Another thing, as mentioned earlier, is we have multiple inundation zones that overlap the same areas. So here we have Moab, Utah. These orange lines here represent the inundation zone. We have a protected area here and a natural gas pipeline here. And then here's a second inundation zone that overlaps the first. And then we have a third inundation zone that overlaps. So this is a very common phenomenon that we're seeing across Utah, where we have multiple inundation zones going through similar areas, heightening the chances of risk in those areas. I'll hand it back to Courtney.
So some preliminary analysis and looking at the dam attributes of height, storage, and age, we're finding very few correlations with the actual vulnerabilities. There are a few higher dams are associated with more of the protected areas and the natural gas pipelines. Older dams are associated with a few more pipelines and power plants. But in general, we don't see strong correlations here. So it would be I think what this tells us is we have to be really careful in just saying we're only going to focus on the high storage, old dams for our analysis, and because we are seeing vulnerabilities nevertheless across the scope of the attributes. And so just to sort of finish up, we've got the almost all of the dams are affecting population areas, but of course, the population areas have different attributes, different populations and different characteristics. So we need to look more into those. Protected areas are turning out to be very much impacted by these dams. So we need to dig into that. This is something that we haven't found in the literature. And so we need to unpack a little bit more what's going on ecologically there, what the risks are. The critical infrastructure is definitely a part of this, but not for every dam. So we need to look at that where we see those kinds of things, because it's not really correlated with the attributes. And so what we're trying to do here is to develop this prototype so that we can use some of the methodologies and use some of the basic geospatial tools, and then work towards a much more sophisticated geodatabase with analytical capacities. And that's what we're doing with iGuide, and that work is underway. Next steps that we're working on, we're wanting to include the attributes of these dams. So, of the entities, like hospitals, how many beds are there? Pipelines, what are we looking at here? All these power plants, what kind of power, all of that. So we can combine the complex information to better understand the vulnerabilities. We can bring in the federal dams into the analysis. All of this is meant to lay a foundation for us to then go in and do qualitative social science research to understand the interactional capacity amongst these different entities and how well they're communicating, the dam managers are communicating with them about the risks. We want to bring in more of the contextual information. So we have Dave Tarbotton and his team and others at Purdue with Venkatesh working on the modeling of these dams. So we can try to understand, are we going to have a foot of water, an inch of water, multiple feet of water? What's that flood going to look like? That's really important as we look at what the impacts will be. And again, the geodatabase, and then really trying to better understand these inundation zones, as we're learning that there might be some inaccuracies to them because some of them were digitized from the back of envelopes 30, 40, 50 years ago. So we need to increase use our tools to gain better accuracy. Thank you for your time.